Okay. Number 1. Okay, so we're given a function, it's increasing, they want the value of that, which the following is true. Okay, so the first thing I would do, there's a couple things you can do on this problem since it's calculator active. One, you should probably figure out what the actual value is. That'd probably be a good idea. Because then you know if your answer that you're given, so let's put it this way, let's pick a number right in the middle. If the answer to the actual integral is 10, could the value of 6.876 be an overestimate for the actual integral?
No.
No. And same by the same token, if the answer is 10, could 13.133 be an could 13.133 be an underestimate for the problem?
No, senor.
No. So these are some things that could help us depending on what the actual value of that integral is. So those are things we can do that for 1. 2, we should know what it means that if a function is increasing, we should know if a right Riemann sum is an overestimate or an underestimate right off the bat before we even do that to begin with. So we have to remember there are 2 types of increasing functions. You can start, or actually, I guess there's 3. So you have your linear increasing function, which is one we can talk about. You can have your concave down increasing. That's a little too concave down. You can have your concave down, or you can have your concave up. Those are your 3 different types of increasing functions that we can talk about. If we are using a right Riemann sum, that means as we go to draw our intervals, so I can just do a rectangle there. I'll make it like there. And notice how I don't really necessarily care if they're the same width or not, kind of in the same place. I just kind of picked them. If I do a right Riemann sum versus a left Riemann sum, that tells you which one is the height of your rectangle. So on the first one here, if I use the right endpoint and make a rectangle, that means my rectangle would be there. If I do it on this one, and if I do it on this one. What do I notice about all of those rectangles?
It's an overestimate.
That is over the graph, making it an overestimate. So no matter what kind of function I have, whether it be linear, concave up, concave down, etc., because it is increasing, I know that my right Riemann sum is going to be an overestimate. So that automatically throws out A and C. Now, instead of actually doing the Riemann sum again, I would do the integral. Instead of actually like getting the actual Riemann sum and doing all that work, which you could do if you really wanted to, I would just figure out what my value for my integral is and go from there. Now, it could be a little misleading, technically, I guess, if you get a very small value, like 5 or something like that, then both of them could be overestimates, then you might actually have to calculate it. But I would definitely do it that way. Deborah, we don't need to hear what you're crinkling.
That was me.
That's not me.
No. I just made an assumption. It tends to be her. So the answer ends up being D, because obviously it's an overestimate. If you do the actual Riemann sum values, which you can do in your calculator, then you get like 13.13. So that's why. I would do the actual integral. When you do the actual integral, with those 2 numbers being so far off, they're not going to be that, it's going to be really hard. So the actual integral is like 10 something, I think, or something around there. Okay, so for number 2, all you have to do is an actual midpoint Riemann sum. So if we're going from 0 to 1, what are my, and I'm having 2 rectangles, right, 2? Yeah. So the first thing I would do to myself at this point is I would not actually graph the real function. I would just graph an idea on the x-axis of what I'll be doing. So if I'm going from 0 to 1, and I want two rectangles, well, the first thing I'm going to do is break it into 0, 1/2, and 1. Now, what points am I going to use for my rectangles if I'm doing a midpoint Riemann sum?
1/4 3/4.
Correct. So we use 1/4 and 3/4. So whatever function values these are, I believe it's this, will determine our, I don't know if you guys can see the different colors, but I'll try. So those middle values will determine our heights. So our width for both of them will be 1/2, and then times f of 1/4 plus 1/2 f of 3/4. That'll be the areas of both of those rectangles. Now, if it looks like this or not, I don't know. I don't really care. This is just a graphical representation of how I would find my area. Those values could be almost identical. They could be way off. They could be whatever we wanted to, but that's what we would find. And remember, this part, because I believe this is again a calculator, you would find these parts in the calculator, so you don't have to do them by hand. That's not too bad, x squared equals the negative x. Yeah, you're definitely not finding that by hand. Okay, do I need to finish that part up, or is everybody okay? That's a lot of silence.
I'm okay.
I'm good.
Sounds great to me, O'Donnell.
Thank you, Annabelle. Okay. Number 3. Oh, you guys hated these problems.
Still do.
They're so easy. God, you guys killing me with these problems.
No, I got this one wrong.
Oh man. So what does it mean for G to have a relative maximum?
The second derivative is negative.
No.
The derivative is going from positive to negative slope.
Not correct. You kind of screwed yourself out of a point there.
Wait, was I close?
Yes, you had everything
Okay.
until you added one word.
Slope.
Yep.
When the derivative is going from positive to negative.
There you go. So G prime goes from positive to negative. If we say G prime has an increasing slope or goes from positive to negative slope, that is then talking about the second derivative. You have to be careful on your justifications. So we need G prime to go from positive to negative. Okay, so we have to find G prime. Well, in our case, G of x is equal to the integral from 0 to x. Instead of writing out that really nasty function, it doesn't matter if it's really nasty or not, I'm going to call it f of x. Now, at some point off to the side, if you're going to write this out like on your AP exam, you would need to write f of x equals blah, whatever that blah is. And then I can then use it in my notation up here, which makes my life a lot easier. Well, now if I want to take the derivative of g of x, so g prime, that is the derivative, so d dx, of the integral from 0 to x. I need a dx there. Of f of x dx, or f of t dt, doesn't really matter. So the real question here is, what is the derivative of this integral function? Well, we have to remember, if I do the integral of 0 to x of f of x, that is capital F of x minus capital F of 0. I don't ever actually need to find capital F and capital of x and capital F of 0, but I need to remember that is what that integral sign means. The reason I need this, if we don't remember, is because I'm going to substitute that in right here. So this is equal to d dx of capital F of x minus capital F of 0. So what is the derivative of capital F of x?
F of x.
Be a little more specific. We have lots of f's going around.
Yeah, I forget, honestly.
Lord.
It's just lowercase f of x.
There you go. And then we got to be careful. I'm going to write this out just to understand. Don't forget, if you're going to do it, this is a function. So you have to take the derivative of the inside. However, in this case, what is the derivative of x?
1.
1. So you could write times 1 if you wanted to, but you don't need to. Other problems, that will become a necessity because we will have to do that. What is the derivative of f of 0?
Zero.
Why is it 0?
Because you get a value, the derivative of value is 0.
So that's a constant. Derivative of constant is 0. So g prime of x will be equal to, in our case, f of x. So basically, since we need to know where g prime of x goes from positive to negative, we are asking where f of x goes from positive to negative. Now, fortunately for us, this is a lovely graphing calculator question. So you take that function they gave you in the original integral and plug it into your calculator and figure out where that goes from positive to negative. All you gotta do is look at the graph from 0 to pi over 2. Excuse me. And apparently that happens between 0 and 1. Everybody should be comfortable doing that part, right?
Yes.
Okay, so does everybody see how I took the derivative of that integral thing there and got the value I did? That's the important part, because that is the big idea of this part of this section.
Yeah.
Okay, number 4. Okay,
How
so
would I have known to take the derivative?
how do we find maxes and mins?
The second derivative, first or second derivative.
Careful. Again, important words that you're leaving out instead of adding this time.
First derivative test or the second derivative test?
Right. So clearly, I mean, we don't have any information on anything but f. So you could take the derivative of that if you wanted to and do second derivative test, but that'd be a terrible idea. Instead,
Okay.
just look at the graph of the derivative, which is that function. Okay, number 4. We're doing a left Riemann sum this time on an increasing function. Based on our conversation from earlier, which we should have written down, Soph, if I am doing a left Riemann sum on an increasing function, will that be an underestimate or an overestimate?
An underestimate.
Underestimate.
Yay. And Deborah, you echo a lot.
Sorry.
A lot.
I'm using my computer, and I haven't done that before, so.
Well, then don't use your computer.
You're fine.
Note to self.
Bottom left, go to user settings, voice and, I don't know if I cut off. Bottom left, go to the cogwheel, go to voice and video. You can do what's called a push to talk. You only talk if you hit the button.
I am using that.
Well, it's staying open. So are you holding the button down for hours in a day?
No?
Then you're not using push to talk, sweetie. I don't know what to tell you.
I just said something and you couldn't hear me, so like,
I don't know, but your mic is staying open. So, I don't know. That's weird. We'll figure it out. It's okay. All right. So, number 4 is definitely an underestimate because it's an increasing function left Riemann sum. At this point, you don't have much information, so you will have to actually do the left Riemann sum. Does anybody need me to do the left Riemann sum?
Yeah.
Okay, so our left ream, what were the endpoints? Like 0, 1, what were the x values?
One, 3, 4, 7, 10.
Okay, so a left Riemann sum, remember we'll use our left points. So that's going to be 1, 3, 4, and 7. So we need to figure out the width of our rectangle. So if you need to draw it out, that's fine. So 1, 3, 4, 7, 10. Again, this is just for me. Yes, I know this is not how my axis would look. So my first rectangle will have a width of 2. I don't know its height yet. My second rectangle will have a width of 1. Don't know its height yet. Then a length of 3. And then again another length of 3. We just need to figure out what goes inside each of these values. Since we're using a left Riemann sum, the left endpoints will determine our heights for us. So in the first one will go f of 1, then f of 3, f of 4, and f of 7. Use the chart to fill those values in. And then add them all up and you have your answer. The answer being 2.8. Does that make sense, Deb? And for anybody else who needed it.
I did that.
Then I don't know what you did after that. Because when you add them all up, they got an answer of 2.8, which I'm intending to agree with.
I got like 1
What did you put
when
for
I
your...
did it.
Did you get your widths correct? 2, 1, 3, and 3?
I just don't know what I did after that.
Put it in the calculator again and see what happens, because I'm assuming you used a calculator, not doing it by hand. So,
Yeah, I did.
anybody else have any questions on that one?
Nah.
Nah, it's just so easy.
No, not at all. But you explain it to make it make sense.
Well, that's good at least. All right. Oh God, number 5. I hate these with a passion.
Yeah, I didn't know what to do.
I do too.
Yeah,
I
can you
looked
do
at the
this
notes.
one?
I had 2
Yeah.
questions on the notes, and I just stopped.
Yeah.
I got 3.
You got 3?
Yeah, I got 3 this time. Last time I got like a really
Oh, you're still on
different
number
number.
4, bruh. You might want to learn how to use the calculator, bruh.
Oh, you got 3 as an answer. I'm like, 3's not an answer.
I was
Okay, I'm
super
kind of proud of
confused
myself
myself.
because I got all the limit ones right.
That's
And I didn't
really
know.
good, because I know I don't do the best job of teaching them, because A, I hate them, and B, I think they don't need to be in calculus anymore.
Yeah, they're dumb.
Khan Academy helped me.
So a couple of things to point out when you're talking about these that I showed you in class that I'll go over again, because I know it's like I said, we don't spend a tremendous amount of time on these, because really there's going to be like, previously there would have been like 1 multiple choice question on this, maybe 2 if the world was coming to an end. So it really wasn't worth spending a tremendous amount of time on. We talked about it a little bit, and it's a little thing you can pick up on. But we have to remember what an integral actually is. So the integral from, we'll do from a to b of f of x dx. What this actually is a limit of sums. So it's the limit as n goes to infinity of the summation from I equals 1 to n we don't have f of x dx anymore. It's f of x times delta x. No, let me put that up. Is really kind of what we're looking at. So f of x, f of, and I won't put x in there, times delta x. So what we put inside of our function is what's going to be the difficult part here. This is always one of the hardest parts to figure out. And I don't, like I said, don't like this section. But one of the things we do know for sure on how to get this delta x, which is really easy, is always your b minus a over the number of rectangles. So that's going to be really easy to help us out, because we know how many rectangles we're using. We know our a and b. Oh, we don't know we're just doing n. So we know our a and b value in this question is 3 and 1. So So for our problem that we're doing, delta x is 3 minus 1 over n, which is 2 over n. Well, that means that right off the bat, I can eliminate answer choices A and C, because they have 1 over n. They don't have 2 over n. So right off the bat, I've got two things. Now, we have to realize when we go to put things in here, if we look at what a Riemann sum actually would be, we're starting at, what, 1, I think. So 1 plus. So this first little symbol here where we have 1, we start at 1, and we move a value of delta x over. Remember, delta x being the change. That's going to be our first rectangle. So our first rectangle will have a width of delta x. And then we go another one over, and we have 1 plus delta x plus delta x, or 1 plus 2 delta x. That's the concept that we kind of went over when I did it in class, kind of as a refresher. So the hard part here in understanding is we have to realize if I'm going to write this out in a generic way, because I would do it again, I have another delta x, this would become 1 plus 3 delta x. So I'm adding a delta x each time I move over successively. So the thing about this, when I write this in a generic form, it's 1 plus k delta x. And this is actually what you end up putting in your Riemann sum. So in our case, our f of x is what? Sine of x cubed plus 2. So if I plug that into so our function is equal to sine of x squared plus 2. So if I plug that into there and plug my delta x and everything in, then I will get sine of 1 plus k times delta x will be 2k over n cubed plus 2 times 2 over n. And that is why it is d. It is a giant pain in the butt. To be honest, I don't like these problems. I think they're dumb. But things to point out and always look for. That is your delta x. You always want to look for, if it's something like this, that is what we use as our starting value. So I know my Riemann sum, or my integral, needs to start at 1. So my integral would have to be from 1 to something. And then the other thing you can always look at is, as you plug in infinity, do you get your ending value inside of here? That's something that I like to do as a little trick. So in our case, it's the integral from 1 to 3. Excuse me. So if I plug in I being like 1 type idea, then I should be getting a value of 1. And if I plug in limit as n goes to infinity, I should get this 3 value. So if I evaluate this limit right here on the inside of my sign, I better get a value of 3, and which we do, because it's 1 plus 2. So those are things to look at and always kind of consider and contemplate. I do this more honestly as a process of elimination type questions, and we were going to review over them when we started doing our reviews, because they appear in some of the multiple choice sections. But that is the general idea of how I do those problems, because I hate them. I think they're dumb. Any questions? Because I know somebody probably has one.
Would you consider your 1 plus k delta x your x for the function?
Yes, that is kind of your x of what you plug into the function. It'll be your starting point plus k delta x. And that's an easy way to do it. So here on number 6, this is where we go backwards now. So one of the easy things to kind of point out and look at, when I'm looking at these values, I have 3 over n out to the side. That's going to tell me my things like my a minus b over n and things like that. So we do have to be careful. If I look at answer choice C, they got that 3 out in front. You can pull constants out in front. So that 3 over n, I could pull that 3 out front and it becomes a 1 over n. That is possible. The problem is if you look at the 3k over n on the inside of that radical, that has to agree with my delta x on the outside. Because notice, you're going to have 2 delta x's. If we look at the last problem I still have up on the board, you have your, remember that's k delta x, and out here, that's delta x. Both of those have to match up. If those two things don't match up, the one on the inside of the function and the one on the outside of the function, then we're not doing everything properly. So on part C, if I pull that 3 out in front from the 3 over n on the outside, then I can't have that because I have a 3 over n on the inside as well. So it has to be, it can't be C, which also means it can't be D, because I have to have an interval of 3. So it has to be from 2 to 5 in this case, or 0 to 3. However, if we notice and note from before where I showed you the starting value, in this case our starting value is 2 based on the what's inside of my radical. So the answer choice has to be B. Does that make sense?
Yes.
You re-explain the radical?
What do you mean explain the radical?
Like, how did you do it?
Well, what goes inside of your radical is going to be your starting value plus k delta x. So inside of your function will be, let's see, where can I write? I can get rid of this over here, I think. So in our case, we have the summation of f of what you can call a1 plus k delta x times delta x. So when they give you the summation, that's what they're giving you. So a1 is your start value, and delta x, remember, that is your b minus a over n. So that's kind of what you're looking for. The delta x allows you to get your a and b, your starting values of your integral, because it would be, so remember this is the same thing as integral of f of x dx. So b minus a will give you your length from a to b, and your starting value tells you where to start. And I just know it's a radical in this case because that's what's inside of the function. Does that clear it up, hopefully?
Wait, so how do you tell the difference between 0 to 3 and 2 to 5?
So what's your starting value? See how it says 2 plus 3k over n?
Yeah.
That means 2 is my starting value.
Oh.
So I have to start at 2 and go.
Gotcha.
Now, it could have been something different depending on the function, but if we look at the function's a basic square root of x, so that's how I knew it was that. They could modify it and come with all kinds of crazy things, but we'll try to keep it basic. Like this one. This one's, they're trying to trick you. So most people right off the bat would probably pick C. There's an issue with C though, and we'll talk about that as I show. So we know that, get this erased. Okay. All right. So we have integral from 3 to 8. What was it? Square root of 1 plus x?
Yes.
Okay. So now we're going from here to there. So we got to figure out what our starting is, our b minus a and stuff like that. That's no problem. So delta x, very easily 8 minus 3 over n. So 5 over n. When I go to plug in to my function, remember, since we want the summation, it's going to be f of our starting value, so 3 plus 5k over n times 5 over n. Okay, so here they're trying to trick you because when I go to plug in this to my function, this will be the summation square root of 1 plus 3 plus 5k over n times 5 over n. That's a triple 5.
Oh.
And 1 plus 3, we can put those together, giving you 4. So they did try to trick you on this one because of how they have the problem set up. So this 4 here is not your actual starting value by itself. It is actually the original 1 plus the starting value of 3. So it is a slight trick. Again, things to point out as you're talking about these. Always ask yourself, if I plug in like my first value, am I going to get, if I plug in I being 1, am I going to get the whole thing of the first value I want, which is a 3? Things like that, which is where you got to kind of be careful. I always, again, do the limit. If I take the limit as n goes to infinity, I better get an 8 value type idea and everything when I start to plug that all in. Or sorry, not n, k. So as k goes to infinity, n goes to infinity, I should be getting these same values, all this kind of stuff. So it does become a little tricky to do. So this one on 7 going backwards would be much more difficult. Going forwards, not too much of a problem. But going backwards does kind of suck. On to an easy question finally. Yay, real calculus. Number 8 should hopefully not have been too terribly difficult. Well, probably at the time it was, but now it should not be. After our discussion from earlier. So what happens when I take the derivative of an integral?
The integral part disappears and you're just left with the f of x.
Careful, not just the f of x. We have
Or
to
like
be careful.
the inside of it.
So we have to then plug our x in. We have to, and I'm assuming in a second we'll get to another example where it's not just super straightforward, but you're basically left with the function. So I have no clue where they got answer choice like D from. B makes sense. I see where they got B from, but B is wrong because you have a cosine in there, and I have no clue what. I see where they got C from too. That's terrible though. I'm saying choice being A. So when you plug in, remember the whole idea with the capital F of x, and then taking a derivative of it ends up right back to the function. So that's like saying, oh, if I add 2 and then subtract 2, those are inverse operations. They cancel each other out. Doing an integral, doing a derivative, cancel each other out. However, I am left with that x being into the original function. So sine of x to the 4th. And I'm sure they'll try to trick you here in a minute. Okay, looking at number 9. The graph of f shown above consists of 2 line segments. How do I find h prime? Just in general, what is h prime?
The derivative of h.
Thank you, Deborah.
It's gonna be like f of x, right?
Yes, thank you. So if we look at this function, h of x is 0 to x of t dt. So when you take the derivative of that, you do end up right back with f of x. So really this question when it says h prime of 4 is the same thing as saying, hey, what is f of 4? Well, f of 4 is 5. So the answer is 5. That makes sense to everybody.
Yeah.
Does it make sense to the people that aren't saying anything?
Yes.
Yeah.
They're not going to talk, so it doesn't matter.
Not my microphone.
Si, senor.
It does make sense. Thank you.
Oh my god, Ashley spoke without me calling on her. It's like a miracle.
Take a lunch break. I'm hungry.
Yeah, 18 minutes. You may have a lunch break. Okay, then number 10. Number 10 is where I told you they would try to trick you. So
Yeah, I got this
2
one
plus
wrong.
t squared.
It worked.
It usually does work when they try to trick you. They know what they're doing. They've been in the process of tricking students for many years. So integral was, I think, negative 1 to x squared of what, 1 plus t squared or something like that? Did I get that right?
2 plus
2 plus t
big
squared.
difference.
Yeah, you're right. It is. It's a huge difference. Okay, so if I'm trying to take the derivative of that, remember, you never actually take a derivative or an integral when you're doing the antiderivatives with this kind of stuff. We don't know how to take the antiderivative of this. You're not going to be able to do it by hand. It would take a lot of work. But remember, I'm going to write this as my f of x, or f of t in this case. F of t dt. So the integral of this would be capital F of x. It was what, x squared, I think, on the top. Actually, I missed that. Yeah, x squared. That part actually is really important. F of x squared. So we end up doing capital F of x squared minus capital F of -1. Well, what happens when I take the derivative of capital F of x squared?
It becomes
Be a little more specific.
lowercase.
Okay, so we gotta be careful though. It's lowercase f of x squared.
Square.
But I'm not done. Why am I
Times
not
2x.
done? Y times 2x, Miguel?
Because it's a chain rule.
Because it's chair. Oh, that's an x cubed. My bad.
Oh, well.
This is one of the reasons why I told you guys you'll be taking on a computer. For one, it's already hard enough to see on a computer. I could only imagine if you're doing this on a phone. So f of x cubed times 3x squared. This is a chain rule. Do not forget that. This is where I told you they were going to try to trick you. You don't just plug in the bound to your function. You have to then multiply by the derivative of the inside. This is two separate functions up here with the capital F. So your outside function is capital F, and your inside function is x cubed. So we hopefully remember those derivative rules. Derivative of the inside, or derivative of the outside, leave the inside alone, going crazy, times the derivative of the inside. And then what is the derivative of capital F of -1?
0.
Is 0. So that is why our answer choice here will be answer choice D, not answer choice B. B is the only other one that makes sense. But that would be if you forgot to multiply by the derivative of the inside, which is a common occurrence. So please don't do that. Alright, question 11. Select by differentiable function, blah, as at least possible critical points. Okay, so how do I find the critical points of f? What are the critical points of f? Like, what does that mean?
Where
The
it's
zeros.
0 or undefined.
Neither of you said, or at least I didn't hear the important part of that. So 0 or undefined is important, but
It changes from positive to negative.
that would be a maximum.
On f of x.
It just changes sign.
Yeah, it just changes sign.
What is it?
F of x.
The derivative.
Function.
The derivative. So f prime, where does f prime change from either positive, negative, or negative to positive? So changing sign's fine. In other words, I need to figure out what is f prime. Well, hopefully after our conversations on previous questions, what is f prime of x?
H of x.
It is h of x. Just take the derivative of that integral. There's no fancy x squareds or anything like that, so it's literally just h of x. So this question in secret is asking you, where does h of x equal 0? Or how many times does h of x equal 0? So we look at our chart. Well, it's never 0. So does that mean there's 0 times it's 0?
No, because it changes signs twice.
Okay, but you're missing out on one important part. Now, they didn't try to trick you here, which is very nice, but you're missing out on something. We can only use the changing signs if what is true.
If it's continuous.
If it's continuous, because I'm assuming, and hopefully everybody remembers, you're using the IVT here to prove zeros. IVT requires continuity. Is h of x continuous?
I mean, I'd hope so.
There's no hoping. We have to say yes or no.
It is.
Okay, why, Miguel?
Because it's differentiable.
Because it's differentiable, therefore it is continuous. They don't ever go on to say the full thing there, but the IVT does hold because h of x is differentiable. We're going to say it's continuous over the entire domain. So yes, and then as Annabelle has already pointed out, it changes from positive to negative or vice versa twice. So there's at least 2 critical points.
Wait,
It could
it
be
changes
more.
from positive to negative,
And then negative to positive.
or h prime of x.
No h prime.
Okay, but it's only.
We're looking at h of x because h of x is the derivative of f of x. So h of x goes from positive to negative, from 2 to 6, that's one change. And then from somewhere between 9 and 11, it goes from negative back to positive. That is your second change. So h of x changes signs at least twice. It's important to note it could be more because we don't know what's happening in between those, but we are only looking for the least possible values. So it has to do it at least twice. The trick here is they're not going to give you this weird function being an integral, and then you're not going to look at h prime of x and go, oh, it changes sign once. That's where they're trying to throw people down the wrong path that aren't really paying attention, and things like that. So you do have to be careful, and I'm always on the lookout for that personally, where if I feel it's a little too easy in some cases like that, then I'm like, they gave me this really weird function, but then I don't need to use that function at all for anything. That throws me a clue that that's not right. I'm doing something wrong there. So we only had to look at h of x, and that changes sign twice. All right, question number 12. Similar idea again, but now we're looking at where it is decreasing and concave up. So what does it mean for g of x to be decreasing?
F of x needs to be negative.
So before we even go there, g of x is decreasing means what? Let's go back a little more basic.
The derivative of g of x is negative.
So derivative is negative. So let's just say less than 0, make it a little better mathematically. And then we also want to know where g of x is, well, concave up in this case, I think. Right?
Mm-hmm.
So what does it mean for g of x to be concave up?
The slope is positive.
The slope? What slope?
The slope of the.
Okay, so you're jumping to the second part of the question. We want to go even more basic than that. What does it mean that g of x is concave up? Go even more basic. What's the most basic definition? How do we know it's concave up?
If its second derivative is positive.
Okay, so these are the two things they're looking for. We now have to tie that to the information in the question. So they gave us that the g of x is the integral from 0 to x of f of t dt, I'm just going to call it. So we need to figure out g prime and g double prime. So if I take the derivative, so g prime of x will be equal to f of x. And then g double prime of x will be equal to f prime of x. So I want to know where f of x is greater than 0, and where, or sorry, less than 0, because we're doing decreasing. My bad. Backwards.
Wait, I have a question.
What?
On like the AP exam, do you need to write out the FTC every time you do problems like this?
Define right out the FTC.
Like with the whole f of x minus f of 0 or whatever, and then the 0, like, do you have to write all that out?
Do you see what I have on the board?
Is that good? Like, can you do that on a test?
But do you see what I have on the board?
Yeah, I'm saying, is that good? Like,
That which I have on the board is 100% justification for things
okay,
if they said
cool.
justify. So you don't have to show out that this is equal to capital F of x minus capital F. You can just take the derivative. That's the same thing as like, oh, I know the derivative of x squared is 2x. Do I have to show anything out there? No. If you know that the derivative of that is f of x, just write the derivative g prime of x is equal to f of x.
Okay.
So this would be if they said justify why is it like concave up, you could say, oh, well, g prime of x is f of x, and f of x is less than 0 here. So this is showing out the entire thought pattern that would be needed to show out if I said, hey, justify this answer. How did you get that? Or that would be like an explanation type idea. So yes, that is perfectly fine. So now we just have to look at our graph and say, okay, well, where's f of x less than 0? Well, that's really easy, from 0 to 2. And then we can look at our second derivative, which is f prime of x, and say, where's f prime greater than 0? What does it mean on the graph that f prime is greater than 0?
Oh, 1 to 2. I mean, having positive slope.
There you go. I was like, what? Don't quite think that, but okay. So f prime being the derivative, you have one of two options. You could have said where it has positive slope, which is what Miguel said, or you could have said is increasing. Either of those would have worked. Since we're not even looking at the 0 to -2 region over there, or -2 to 0, however you want to say it, I don't have to worry about that. I'm only looking at from 0 to 2 at this point. So here we would say that from 0 to 2, the function is increasing on the interval from 1 to 2. So our answer choice being D at that point. Does that make sense, hopefully?
Yes.
I haven't decided yet.
Okay, well, when you figure it out in about 3 months, let me know.
I will not be doing calculus in 3 months if I can avoid it.
That's what you think.
Ooh, gets old.
Let's see. Did I skip a problem? No, I didn't. Okay. Number 13. Pretty much the same thing we just did. Oh, no, it's not. Why is that in this section? Okay, everybody should have gotten this one correct. It's literally just an integral. It's very strange that they would put that in this this section, but okay. Hey, there you go.
The 3 I got right.
If you didn't get this one right, you may want to ask yourself why. It's pretty straightforward. Just integral from -1 to 3 is just the area under the curve. So you have a rectangle on the left, and a triangle is what I would do, and then a triangle being positive. So that's pretty straightforward. I hope everybody knows that one. I'm going to take that back. I know everybody knows that one, whether they made a mistake or not. But I know everybody knows how to do that.
Yeah.
Okay, and number 14. That shouldn't have been too bad, I hope. Do I need to do 14 for anybody? Speak now or forever hold your peace.
Nah.
Yes.
Oh.
Yes, do it, Nolan?
Yes, please.
Okay. 3. So don't forget, according to our integral rules, we can break this up to the integral of 3 f of x minus the integral of g of x, and they both get dx's at that point. And I can also pull the 3 out front, so 3 integral f of x dx minus integral of g of x dx, whatever the bounds are, and they gave us that information, so you just plug those in at that point. So it's at 0 to 2 on all of them. And they gave us both of those values. So you just plug them in, multiply the first one by 3, and then subtract them. Everybody good with that now? Questions?
No, that helps a lot.
No problem. Ooh, I bet number 15 scared a bunch of y'all. You guys hate piecewise.
I tried
Yes,
really
you do.
hard and I just couldn't figure it out.
What am I going to tell you guys to do?
Get smart.
Calculus.
What's the first thing I always tell you guys to do when you're doing integrals of these functions like this?
Graph.
Graph it, especially because this one's really easy. What's the graph of 2, 3, and -1 all look like?
Horizontal lines.
Yeah, just a bunch of horizontal lines. So when you go to graph, you need 2, 3, -1. Let's see, 2, 3, and 8. So it's that. Oh, and yeah, it's 2, 3, -1. And then that. And then that. So just find those areas and add and subtract. So this is a rectangle of 2 and 2, so that's 4. This is a rectangle of 1 and 3, and that's 1 of 5 and -1. So 9 minus 5 is 4. Unless I did I did my math wrong. What did I do wrong?
I feel really stupid now.
Oh, because I can't. You figure out what I just did wrong, because I'm a moron. Nobody's gonna make fun of me? For
4
real?
plus 3.
You just somehow cancel out the 3 and the 5.
I said 4 plus 3 was 9. 9 minus 5 is 4.
Oof.
Yeah, I was like, you pulled a me, Mr. O'Donnell.
Like, and I'm like legitimately like I saw it and I was like, oh man, they're about to like roast me, and y'all barely caught on. It's not good.
It's Monday.
So I
I mean,
can't.
I knew that math is wrong, but how was I supposed to know you got 9?
Well, you were supposed to just
Yeah.
roast me for the fact that I did 4 plus 3 minus 5 wrong.
Okay, fair.
Didn't matter what I
I'll
did it wrong.
it.
Touche.
All right, we will end there for today since it is 11. Make sure you are doing the other multiple choices for tomorrow, especially now that you have some help there.